So welcome to this last presentation before the drinks. I hope to keep your interest before going for that social event. So let's start. We will discuss a bit about Istio, and this will be the third talk today about Istio, as far as I counted. So I hope I will be able to show something else as well. First, a few words about us and myself. So I'm Laszlo Budai, CTO of ComponentSoft. I'm a senior instructor and consultant. I have some over 20 years of Linux experience, and currently I am mostly interested in these open cloud topics like OpenStack, Ceph, Kubernetes, and Istio. About our company, ComponentSoft started out some 25 years ago as a Sun educational partner in the time of Sun Microsystems, if some of you remember that. And nowadays we are mostly involved in these open cloud technology trainings and consultancy. We have educated some over 2,000 people, mostly for telco companies like Ericsson, Deutsche Telekom, Nokia, and so on. And also we have consultancy assignments and support assignments with these kind of companies. Our current important topics are, of course, OpenStack, Kubernetes, Docker, and Istio. And before getting to the technical stuff, I just want to remind you two things. First, for all the participants, we have a promotion. So if you register to our trainings with the promotional code, we will rock you, then you will get a 20% discount. So I hope that will rock you, really. And also, for those who have registered at our booth, there will be a raffle at the end of this presentation. So we will have two winners. One will get a free seat at one of our trainings, and the other one will get a ticket to the Denver Open Infrastructure Summit. OK, so it's worth to register. Good. Let's move on then. A few words before going forward about you. So in this room, who has heard about Istio? Wow, that's great. OK. Who has been at the other two presentations today about Istio? Okay. The presenters, at least. Good. Let's see a bit then what are we talking about. So probably all of you have heard the concept of service mesh. It was mentioned a few times today. And what is this service mesh? Well, to see where the role of the service mesh is, we have to see how application development has evolved in the current days. So nowadays, we know that applications are moving towards the cloud, and once upon a time, monolithic applications are broken up into small services, microservices, which can live their own lives. So that's important here. They can scale independently from each other. They can have different versions independently of each other. And they will communicate with each other, calling their functions. So if we had a monolith before with some functions which were calling each other in order to provide a functionality, a service, now the microservices are calling each other. And we get a good thing that all those microservices can scale independently, can have their own life, their own development, and so on. But we brought something into the picture which was not here before. I mean, those microservices, which were, let's say, functions before, they were communicating with each other, but they were in one process space. So calling one or the other, it was just a simple call, a jump, if you want, in CPU. Now, calling each other, it means they have to call each other over the network. Okay, and that's where all the problems start. Okay, so that's where the, let's say, the happy story stops, and then we have the problems. And why is that a problem? We know with network, well, you can have any kind of surprises. The network can be down, the network will bring delays, the network can be sniffed by someone, and so on. So we have quite a lot of problems which we have to solve. And how can we solve it? Well, we have different options, of course. We can use libraries. We can build those libraries into our code. And those libraries will do for us encryption, will do for us retries, will do for us so on and so forth, the different functions. But then we have to take care to some even more code, the libraries. So those have to evolve with our own application. Or we can say we would like to delegate those tasks to someone else. And that someone else, let's be something in the infrastructure, and that's what the service mesh comes to help us. Okay, so the service mesh will try to provide all those services for us which we don't want to care about. Okay, as an application developer, we just want to call the other service, and that should work. And what a service mesh it is, well, we say a service mesh, it's a dedicated infrastructure layer which controls service-to-service communication over the network. Okay, so that's what the service mesh is in a one-sentence definition. What is doing the service mesh is handling things like service discovery, routing, very important, how to route our traffic from one service to the other, fault resilience, so if we have a networking problem, how do we try to mitigate it, security, very important, and observability. Observability meaning that we have metrics, we have traces, we have logs about our traffic. Then what is Istio? Because we had Istio in the title. Istio, it's a service mesh implementation. It's an open source service mesh. It's interesting, it can be transparently added to our existing applications, so it doesn't require any change on the application code. And it has those features that we have mentioned, like service discovery, load balancing, traffic management, fault recovery, and so on. Okay, so that's what Istio it is. And then let's see how it is working. So Istio, in order to handle this traffic, it's inserting a so-called sidecar proxy next to our application. That sidecar proxy, it's capturing all the traffic, and then programming that proxy, we can achieve those functionalities that we have mentioned before. In Istio, that sidecar proxy is a modified Envoy proxy. The other components on the picture, we have the mixer. Mixer is providing us policy controls and telemetry collections. So every request can pass a policy control, and we can decide whether that request is allowed or not. And also Mixer can collect telemetry for us and connect our service mesh to our infrastructure service provider. So if we have a logging service in our infrastructure, or if we have a monitoring service, then through the Mixer, we can connect that data which is collected in the mesh by the Envoy proxies to the infrastructure service providers. Then we have the pilot. A pilot is the component which is responsible for configuring our envoys. So the pilot will provide us an API interface where we can define platform-independent objects like destination routes, service entries, and so on, virtual services. And those are translated into Envoy configuration parameters and pushed to Envoy. Also, Pilot does much more than this, like service discovery, interacting with the infrastructure, and so on. Citadel, the other component, this is providing identities for our microservices. So if we are talking about authentication and authorization, authorization cannot be done without identities, without the concept of identity. Okay, so Citadel, what will do for us, it will create certificates for each of our workloads. It will deploy them into our sidecar proxies so they can authenticate against each other. And finally, the last component here is Galley. That is, let's say, an ingestion engine where the user created configuration is translated into configuration for the other components. So the other components should not be aware how the configuration is stored, for instance, in those custom resource definitions or so on. A Galley will be the one who will read those and will configure internally the other components. Now, about the security needs for our microservices. The first thing what we want in our microservice-to-microservice communication is to have privacy. So the data should not be readable by others. Okay, so we need there a traffic encryption. Okay, so that's one need. The other need is access control. So we would like to be able to control who can call on a certain service. Okay, and then we have the need of auditing the traffic, what's going on in our infrastructure, how the communication happens between those components. And these are handled by Istio. So these requirements that we have mentioned are handled by Istio. The security features of Istio, well, Istio has some goals related to security. One is to be secure by default. Secure by default, it means that we have an application, we have our microservices, and we don't have to change anything on those microservices and still be able to achieve those features that we have mentioned before. So to fulfill those requirements, to have encryption, to have authentication, authorization, auditing, and so on. Okay, so that's what we expect from this service mesh. Then defense in depth allows us multiple layers of defense, and it allows us to integrate our service mesh with our infrastructure. And zero trust network. So we are always assuming that the network is, we cannot trust the network. Okay, so anytime there can be some intruders there, or we can have some issues, data leaks on the network. So we should build a secure communication channel over an untrusted network. Okay, so that's very, very important. And then the features that it provides, Istio can do encryption of our traffic, can do authentication using mutual TLS. Mutual TLS, it means that both sides are authenticating against each other. So when we pop up a browser, usually we are authenticating the web page. So we are checking, is that certificate known by us? Is that trusted? Usually we are not providing a certificate from our side. But here it's a different story. Those microservices are doing this mutual authentication. Then another important feature here is service identities and secure names. Those service identities are created and managed by the Citadel. So Citadel is generating the certificates and is renewing them when needed, so when they expire. And the secure names will assign identities to service names. What does that mean is that if someone managed to hijack the traffic of a certain service, then, and it has some identity from the mesh, then the client will be able to recognize that, yes, I have the CA, the certificate authority of that certificate, I should trust it, but I am not trusting it because its identity, I mean that certificate, should not serve this request. Okay, so that's what service name, secure names it is. Okay, so Pilot will maintain these secure names for us, for our services, and if this will happen, then it will refuse, the proxy will refuse to communicate. What else we have here? We have authorizations using role-based access control. So Istio provides these concepts of roles and role bindings, somehow similar to Kubernetes, but with some more details. And we have the concept of policies. So we can create here, we can integrate Istio with some external policy providers. And we have also some out-of-the-box policy providers like white blacklisting, rate limitings, and so on. About MTLS, as I mentioned, Citadel is the one who is providing the identities to the workloads, and the authentication is performed at the proxy level. Okay, so actually proxy to proxy will do this authentication. We haven't changed anything on our application. Actually, our application is not aware at all that there will be some authentication in between the two endpoints which are trying to communicate. Okay. And as I mentioned, secure naming is maintained by Pilot, and that information is also configured into the Envoy proxies, so the proxy will decide whether it will trust the other end and it will send the request there, or it will just fail. How do we configure MTLS in Istio? When we are configuring MTLS, well, we have the two sides, the server side and the client side. The server side is configured by policies, and we can specify those policies at different levels, at namespace level or mesh level. And we are specifying that, yes, we want to have MTLS policy enforced. In Istio, we can have the MTLS configured as permissive, which means we are accepting both HTTPS and non-HTTPS traffic, so plain connections. If we set that the peer authentication policy is MTLS, then it means that this is enforcing. And, well, we can set it per target. So, for instance, we can specify this just for certain workloads and so on. Those are just some details. What is important to understand? The policy is applied on the server side. Okay, so it's applied on the server side. The server for which we have configured that it should accept only TLS connections, and it should do that mutual TLS authentication, will expect that the clients will follow the rules. Okay, so the clients will follow the rules. And in order to configure the client side, we have this possibility in the object called destination rule. So the destination rule, it's a configuration object for our Istio, where we are configuring the rules of connecting to some workloads. Okay, so how do we connect to those workloads? And here we can specify that for the host service A, our traffic policy is TLS in the Istio mutual of the Istio mutual type. And once we have this part done as well, then the client will send this TLS authentication, and it will try to build up the TLS connection with the server, and hopefully it will succeed. A few words about role-based access control. For the role-based access control, we have here two objects. We have the concept of service role, and the service role allows us to specify what is allowed. So actually, the service role, it's a collection of permissions. What do we want to allow for someone who has that role assigned? And here we can specify things like for which services we are referring to, what methods do we use, but also we can set up some interesting thing, which is the constraints. So we can say this applies only if the request header contains something, or only if there are some other conditions satisfied. So actually, if you would compare the role-based access control and attribute-based access control, you can see this is somehow a mixture of two. Okay, so we have both roles and attributes here. And then we have the concept of service role binding. And the service role binding, as the name says, it will bind a role to a subject. Okay, and here again, for the service role binding, we can assign that role to a subject, but we can also set up some properties which are similar to the conditions from the role. It says this binding will happen if these properties are met. So if the request header contains something, for instance. So actually, we are applying that rule only for those requests which have the user agent's URL, okay, and so on. So this is how the role-based access control is working. And if we have configured these two, then it will be applied. And of course, only those subjects, those requesters who are satisfying or who have that role assigned will be able to do those calls on our service. Okay, so this is how we configure these things. And now let's try out a bit how these things are working. Okay. So I will bring some terminals into the picture. So what do we have here? We have a Kubernetes cluster with Istio already installed. So if kubectl get node, then we have there a master node. Okay, I think I will have it this. Okay, is better? So we have here some nodes. Kubernetes is running there currently. Okay, so we don't have anything deployed yet into our Kubernetes. And we have Istio running. So these are the different components of Istio which are deployed, just to make sure Istio is here. Also, you may probably know that Istio can do auto-injection for us. So that sidecar, how does it get into our workload or next to our workload? We can do it manually, or it can be enabled to happen by default. In our case, it's already enabled. Okay, so actually, for Istio, we need a certain label to be set on a namespace in order to allow this automatic sidecar injection. Good. Then let's try the current mesh policy related to TLS. Okay, so okay. So currently, we can see the policy is permissive. Okay, so it means that both HTTPS and HTTP are accepted. Then let's pop up some workloads. Okay. I have here an HTTP bin. Which actually creates a service, which the service port will be 8000. The target port, I mean the port on the pod, which is exposed, is port 80. And it has a deployment where in the deployment we are running an HTTP bin binary. This is a tool which can be used for testing HTTP applications. So okay, it says that the service has been created, the deployment has been created. Now, what we want to test is, let's try to capture the traffic for that pod. Okay, so I will list where my pod has been scheduled. We can see it's running on worker 1, so on the node worker 1. So I will go to that node, and I will start a TCP dump kind of action. Okay, so okay. I will use the T-shark, is the Wireshark in text mode. And I will try to capture the traffic for port 80, which was the port for my pod. Okay. Now, to see what's happening, we will use another container, which will be our other microservice. So right now, HTTP bean is one of our microservices, and we will start another one where we will run CURL. So I'm starting up a sleeping container. For us, it's important that container has a CURL tool which we can use in order to connect to our service. That's a different URL. OK, let's see. Sorry. One more time. OK. Yeah. OK, so now I am in the sleep container. And I will try to use CURL to connect to the other one. So and the HTTP bean service is exposed on port 8000. And here we are. We got a response. But here, if we are looking at this capture, we can see our traffic. So actually, we can see the requests here, everything. So we can simply capture the traffic and read what data flows there. That is something we don't want to happen. Okay, so we have to turn on the TLS authentication. Okay, so let's do it. I have already here YAML for this. So we just simply say that use MTLS for our traffic. So OK. And again, let's understand what happened. We have turned on the MTLS as a policy, which means that we have configured the server side. OK, so our servers will expect the clients to open up TLS authenticate and to authenticate themselves, and of course to open up an encrypted connection. Now let's see what will happen if we try to go to this workload again and try the CURL command. OK, so it says upstream connect error or disconnect reset before headers. Why? The Envoy proxy on the server side was expecting TLS connection, but we were sending plain HTTP. So the Envoy on the server side has refused. And if we are looking here, let me just repeat this so we can see it better. We see that from the client side, we have sent a plain HTTP, which we were able to see. But the response, it was a TCP reset. So the Envoy on the server side has said, stop here, reset connection. I will not talk to you, right? OK, then let's fix this one. We will have to tell the client, please use MTLS. OK, so I will say something like kubectl. Oh, not here. No. Actually, before doing this, okay. So what we have here, it's a simple destination rule setting where I'm saying the traffic policy, it should be TLS, Istio mutual, which means you will get the certificate from Citadel, use it for building up the connections. So Okay, and I will go to my sleepy container again and try this. And here we are. We got the response. Let's see what happens here in the capture. I will repeat it. So actually, we cannot see anything. It's an encrypted traffic. Okay, so we have here an encrypted traffic. It says, we don't know, it's continuation or non-HTTP traffic. But anyway, we cannot see that get whatever we were able to see before. Okay, so what has happened? We had two applications, HTTP bean and a CURL on one side and the other side. We haven't changed anything. So the command was all the way CURL HTTP bean 8000. On the other side, we started HTTP bean once, and it was just running. Initially, we were able to connect without TLS, but in that case, we were able to see all the traffic because it was a plain text traffic. And then we have encrypted. Okay, so that's what the mesh has provided for us. Okay. Thank you. Yes, please.
Is it still the case that the Istio init container needs to run as root to do its IP tables stuff?
Istio in the container, well, it has to be able to do IP tables because it has to capture all the traffic. So it's up to the permissions and privileges you have there in order to be able to capture the traffic.
The reason I ask is it seems it's a bit incompatible sometimes with the pod security policy when you don't want to run things as root.
I couldn't hear.
I'm just saying it's a bit incompatible with pod security policy sometimes when you want to say things can't run as root. I know there's been some attempts to move that part of the Istio control plane elsewhere outside of actual pods. I don't know.
I'm not aware whether it was fixed or not.
For monitoring purposes, is there any way to disable just for some pods to be able to listen all the traffic that's running between those services?
Wait, monitoring,
Yeah.
the monitoring provided by Istio is happening the following way. The Envoy proxies are capturing monitoring information, and you will configure the mixer how to publish them, let's say. Okay, so it will be up to your policies how you collect those information and then how you configure them. And your question was to allow only some pods to
Be able to listen all the connections between two services. So for example, if I want to read the headers.
But normally here what we have done, it was that we were playing the intruder. Okay, so if you are listening on your traffic, again, you are playing the intruder. Or maybe I misunderstand you.
Let's say I have a monitoring application.
Yes.
That's able to check or listen the connection between services.
But I'm not sure we want to do that. So now we have Mixer, which has the so-called platform adapters. And through those platform adapters, Mixer will talk to your monitoring application.
Okay, so Istio will provide me, for example, any way to ensure that I'm not receiving 404 requests, for example.
To receive 404 requests for what?
Between services.
Between services. Well, Istio, well, I don't see exactly the use case, but what Istio can do for you is one service requests something, you have a response, and then with that response, why should Istio interfere with it? Or I don't think I understand what you...
Suppose the metrics for HTTP errors, for example.
HTTP errors? And you want to count them, or
Yeah, or detect them.
well, you have logs, so you can configure logs, and then you can parse those logs files, and you can see what responses you had. So that's how you could connect your monitoring, which is counting, for instance, these errors with Istio. So you have the possibility to extract those traffic logs, what has happened, if that's what you are looking for. Okay? Yes, please.
I've seen that Istio needs to be deployed as a sidecar container in the pods. Is there any way to deploy it as daemon set?
Well, you have to see daemon sets are deploying only one instance of something per host. But here, Istio is deployed per workload because each workload will have different configuration parameters because one workload belongs to one service, the other workload belongs to another service. So one proxy will serve the traffic for one kind of workload, and the other will serve for the other workload. So I don't think that would be a possibility to do it with a daemon set which deploys only one proxy on your.
The problem is that when you have a lot of pods, this could be a bit overkill.
Well, yes, but this is how it's working, and this is how you can have all those possibilities and all that flexibility which this service mesh provides to you. So it's something for something. Yes, please.
Could you briefly cover what you're going to be working through in your workshop tomorrow?
So we will have some discussion about the architecture. We will do installation and traffic management. So actually, for tomorrow, we will do part of our official training, part of it, of course. Okay. So we will do the traffic management. That will be the larger part of it. Yes, and it will be hands-on. So you will have access to our lab facilities, and you will deploy Istio for yourself, and then you will try out those traffic management features. Okay, so the most important thing of the day, it comes the raffle. So we will see the winners for this stuff.
Obviously you weren't in it. That's a shame. That's a shame. It's the other side. You'll actually be impressed with this. I've always wanted to be a game show host. I'm Graham, by the way. If anybody's doing Kubernetes in the morning, then it's you're with me. Or with the other Graham. It depends which one you're doing. If you're doing the zero to hero, then I'm your man in the morning. Anyway, well, I've always wanted to be a game show host, but not necessarily on Wheel of Fortune. But what we actually have here is, of course, everybody's name that kindly gave us your name for the draw. So we've actually got two prizes. One is a free seat in a Kubernetes training course here in London, which would or online, sorry, or online. If you are in London and you want to actually appear in person and have instructor-led training, then again you'll probably see me. If you do it online, you'll see Laszlo, or you won't see Laszlo. You'll hear Laszlo. Or you put your video.
You will see me.
Yeah. I never do that if I'm doing online courses, just in case I frighten people. So Laszlo obviously doesn't need to do that. We have the two prizes, we have that, and we have the ticket to Denver. There's no flight or hotel in the Denver one, just in case. And the first person's name drawn out, if you are here, you will have the choice of two. So the rules are simple.
Can I start it?
Please do.
either London online or Denver. So which one do you prefer?
I can't do online.
It's your choice.
Yes, I will try.
Online.
Yes.
Okay, so you will meet Laszlo again virtually. This is for the summit. This is for online course, Federico Barcelona. Very nice name.
I don't feel so rejected.
And you can look out the exact dates on our webpage. You already have it. Okay. And Laszlo, please make some photos. Give away. Let's have a handshake. That's it. Congratulations. And now the second one.
Now you have more chance.
All right, yeah.
No, that's me.
So he's not here.
Probably.
Yes, it must be, but actually your writing is not so nice. So, you have a choice. Which one? This is Denver, and this is London or online.
There's only one choice, surely it's Denver.
So you choose Denver, okay.
Totally.
So, Graham, could you write the correct name?
It's Anthony Fairweather. Yeah.
And we can make a third trial because we still have one place and one certificate.
Okay, cool.
Okay, for Kubernetes training in London or online. But first things first, let's have a handshake and a photo with the certificate. Okay. Handshake, smile, photo. Okay.
Thanks very much, guys.
And the last one, and it's not Denver anymore.
Just do it again.
Look, Stephen, like Stephen, we have lots of payable seats already, or yet, if you are interested. And we remember the
discount
code.
Okay. Yeah.
We will wreck you.